Generators have undergone significant changes in recent years, particularly in their electrical systems. These changes have implications for their compatibility with 240-volt breakers. Older generators typically produce single-phase power which is compatible with 120-volt breakers. The rotor and stator windings in older generators were designed to handle lower voltages and currents. These generators had limited overload capacity, making them more susceptible to damage when connected to higher voltage breakers. Modern generators often produce multi-phase power, including 240-volt three-phase or 240-volt split-phase. The rotor and stator windings in newer generators are designed to handle higher voltages and currents. Modern generators have improved overload capacity, allowing them to withstand higher loads for extended periods. Newer multi-phase generators are designed to be compatible with 240-volt breakers. The increased overload capacity of modern generators provides better protection against damage when connected to 240-volt breakers. However, proper installation is still crucial. Generators should be connected to the appropriate breakers and overload protection devices to ensure safe operation. The generators that were damaged may have been misidentified as new models when they were actually older models. The generators may have been connected to inappropriate 240-volt breakers such as single-phase breakers. The generators may have been subjected to excessive loads exceeding their overload capacity. Incorrect wiring connections or loose connections can also lead to damage. Always refer to the generator's manual for proper installation and safety precautions. Use a qualified electrician to connect the generator to the electrical system. Ensure that the generator is connected to the correct type of breaker and overload protection devices. Avoid overloading the generator and monitor its output regularly. To elaborate further on the differences between older and newer generator designs, let's delve into the specific components and their functions. Firstly, let's consider the rotor, which is the rotating part of the generator. In older generators, the rotor typically consisted of a simple winding of wire around a laminated core. This winding would be energized by a direct current source, creating a magnetic field. As the rotor turned within the stator, this magnetic field would induce a voltage in the stator windings, producing electrical power. The design of these older rotors was relatively basic, and their ability to handle high voltages and currents was limited. In contrast, modern generators often employ more sophisticated rotor designs. These rotors may feature multiple sets of windings or more robust insulation materials. Some advanced designs even incorporate permanent magnets to generate the magnetic field, eliminating the need for a separate direct current excitation source. These improvements allow the rotor to withstand higher voltages and currents, enabling the generator to produce more power and operate more efficiently. Secondly, the stator, which is the stationary part of the generator, also plays a critical role in determining its performance. In older generators, the stator typically consisted of a set of coils wound around a laminated core. These coils were connected in a specific configuration to produce the desired output voltage and current. The insulation materials used in older stators were often less advanced than those used in modern designs, limiting their ability to withstand high temperatures and voltages. Modern generators employ stators with improved insulation materials and more sophisticated winding configurations. These stators are designed to minimize losses and maximize efficiency. Some advanced designs even incorporate cooling channels to dissipate heat and prevent overheating. These improvements allow the stator to handle higher voltages and currents, enabling the generator to produce more power and operate more reliably. Thirdly, the overload capacity of a generator is a measure of its ability to withstand temporary surges in demand. Older generators typically had limited overload capacity, meaning that they could only handle brief periods of excessive load before overheating or sustaining damage. This limitation was due to the design of the rotor and stator as well as a cooling system. Modern generators are designed with improved overload capacity, allowing them to handle higher loads for extended periods. This improvement is achieved through the use of more robust components, more efficient cooling systems, and advanced control algorithms. These features enable the generator to withstand temporary surges in demand without compromising its performance or reliability. In addition to the design of the rotor and state of the type of output produced by the generator also affects its compatibility with different types of breakers. Older generators typically produce single-phase power which is suitable for powering most household appliances and lighting. Single-phase power consists of a single alternating current waveform that oscillates at a specific frequency, typically 60 Hz in the United States. This type of power is relatively simple to generate and distribute, making it ideal for residential applications. However, single-phase power is not as efficient as multi-phase power for powering large industrial equipment or machinery. Modern generators often produce multi-phase power which is more efficient for powering heavy loads. Multi-phase power consists of two or more alternating current waveforms that are offset in time. This type of power can be either three-phase or split-phase depending on the specific design of the generator. Three-phase power is commonly used in industrial applications because it provides a more constant and smooth flow of power. Split-phase power is often used in residential applications to provide both 120-volt and 240-volt circuits. To further clarify the reasons why a generator might be damaged when connected to a 240-volt breaker, let's consider some specific scenarios. Firstly, if the generator is an older model designed for single-phase 120-volt operation, it may not be able to handle the higher voltage of a 240-volt circuit. Connecting such a generator to a 240-volt breaker could result in overheating, insulation breakdown, or even a catastrophic failure of the generator's windings. Secondly, if the generator is a new model designed for multi-phase 240-volt operation, it is still important to ensure that it is connected to the correct type of breaker. Connecting a multi-phase generator to a single-phase breaker could result in an imbalance of current flow, leading to overheating and potential damage to the generator. Thirdly, even if the generator is compatible with 240-volt breakers, it is still possible to overload it by connecting too many appliances or devices to the circuit. Overloading a generator can cause it to overheat and shut down, or even sustain permanent damage. It is therefore important to carefully calculate the total load that will be connected to the generator and ensure that it does not exceed the generator's rated capacity. Fourthly, wiring errors can also lead to generator damage. Incorrect wiring connections or loose connections can cause excessive resistance, leading to overheating and potential fire hazards. It is therefore essential to ensure that all wiring connections are properly made and tightened. Finally, it is important to regularly inspect the generator for any signs of wear or damage. Worn or damaged components can compromise the generator's performance and safety. If any problems are detected, they should be addressed promptly by a qualified technician. In summary, generators have evolved significantly in recent years, with modern designs offering improved performance, reliability, and safety features. However, it is important to understand the differences between older and newer models and to ensure that the generator is properly installed and operated. By following these best practices, you can maximize the lifespan of your generator and minimize the risk of damage or injury. In addition to the technical aspects of generator design and operation, it is also important to consider the safety precautions that should be taken when using a generator. Firstly, never operate a generator indoors or in a confined space. Generators produce carbon monoxide, a colorless and odorless gas that can be deadly. Always operate the generator outdoors in a well-ventilated area away from windows, doors, and vents. Secondly, never refuel a generator while it is running or hot. Gasoline is highly flammable and can easily ignite if spilled on a hot engine. Allow the generator to cool down completely before refueling. Thirdly, always use a ground fault circuit interrupter or GFCI protected extension cord when connecting appliances to a generator. A GFCI is a safety device that can detect ground faults and shut off the power to prevent electric shock. Fourthly, never overload a generator. Overloading a generator can cause it to overheat and shut down, or even sustain permanent damage. Carefully calculate the total load that will be connected to the generator and ensure that it does not exceed the generator's rated capacity. Fifthly, always store gasoline in a properly labeled and approved container. Gasoline should be stored in a cool, dry, and well-ventilated area away from heat, sparks, and open flames. Sixthly, regularly inspect the generator for any signs of wear or damage. Worn or damaged components can compromise the generator's performance and safety. If any problems are detected, they should be addressed promptly by a qualified technician. Seventhly, always follow the manufacturer's instructions for operating and maintaining the generator. The manufacturer's instructions provide valuable information on how to safely and effectively use the generator. In addition to these general safety precautions, it is also important to consider the specific requirements of your local electrical codes and regulations. Electrical codes and regulations vary from place to place, and it is important to be aware of the requirements in your area. A qualified electrician can help you understand and comply with these requirements. In conclusion, generators are valuable tools that can provide power during outages or emergencies. However, it is important to use them safely and responsibly. By following the safety precautions outlined above, you can minimize the risk of injury or property damage.